Okay, welcome everybody in this webinar from the Titan project. The Titan project is about enabling transparency in food supply chains via the implementation of digital technologies to boost health, sustainability, and safety of products, processes, and diets. And we are more than happy to welcome two eminent speakers today on topics that are really relevant for the Titan project. We have made for you an exciting program. We have two presentations. One is given by Michele Suman on new detection methods for food safety and authenticity. And the other presentation is given by Francesco Mureddu about the transformative impact of disruptive digital technologies. The setup of the webinar will be that they first will give their presentations. After the second presentation, we have a short Q&A, and then we propose to split up in two groups and to have some discussions in subgroups on the two different topics, and we also prepared some questions for this. To explain about Titan, because Titan has quite a broad area that we are working on, and we have divided Titan into 4 different key expertise areas. The first one is to enable consumers to make informed food choices. And one aspect here is to ensure food safety and authenticity, and the other aspect is more about informing and educating the consumer. The second key expertise area for Titan is facilitating supply chain sustainability. We would like to promote environmental and social aspects to be addressed, and we are also strongly supporting SMEs, and this is also shown, that can be seen in the setup of the Titan project. So these are two aspects that we are passionate about. And then the webinar today is about the third key expertise area, the implementation of new innovative technologies. And this is something that is happening within the Titan project. And we have two different categories. One is faster and or more accurate detection methods. And the other topic is disruptive digital technologies. And then we can add that we are also having some focus on new sustainable technologies that fall outside of these two categories, but these two topics are the most important for us. And then as a fourth key expertise area, we have taking the food system approach, where we want to work with all relevant partners towards a sustainable food system, where we have food security for all, leaving no one behind, and where we let's say, collect examples, best practices, and discuss how to successfully innovate. Yes. Within Titan, we have a stakeholder board. These webinars are specifically organized for our stakeholder board, but we think it's possible that you can also attend without being a stakeholder, but please consider to sign up. It's very easy. You can go to the Titan website and sign up to become a stakeholder. You will be a member of a unique network where you can collaborate with experts, can ask questions, can discuss, and let's say collectively shape the future of transparency and innovation in the agri-food sector. The membership benefits include join this vibrant community, stay informed and contribute, expand your network, you have early access to information and multimedia, and together you can contribute to shaping the future of our food system. We have the plan to organize a final conference, and we also invite the stakeholders to support us with this, to propose keynote speakers, to help with selecting the right abstracts, to make proposals for speakers. And so this is also what we have in the pipeline. Then every 4 months we produce a newsletter that we share on our website. We also announce it on LinkedIn. When you sign up for this newsletter, you will get it automatically in your mailbox. And here you see some news items. There was last year a short article published about Titan with, as the first author, Isabel Guling. She is the coordinator of the Titan project. Then there was the first publication is out from Esra, from the Technical University on Delft, and she is focusing on digitalization. And there was a presentation of Carla from INL and USC, University Santiago de Compostela, about her research, which is more linked to the topic of Michele of today. Linked with this newsletter, we also share a PDF with a long list of relevant scientific papers and reports that we have found in a PDF, so that it's accessible. When a scientist wants to find information about publications, of course, you can always do specific searches. In my experience, it's more difficult to find the reports. So what we have found is in there. It's a huge resource base becoming already. So when people are interested in certain topics, they can go back to the PDFs and find a lot of information. And as a service, we also provide a weekly newsletter, the Titan Weekly, which is always shared on LinkedIn on Tuesday around lunchtime. And this contains news items on the 4 key expertise areas that I presented, but also some proposals for conferences to attend, some webinars in the upcoming weeks, and also some opportunities like to get funding, to do trainings, or to fill in a survey. Then I would like to announce the next webinar. We have to fix the exact date, but we propose February 11th on a Tuesday afternoon, where we'll have 2 speakers in the key expertise area taking the food system approach. Ryan Edwards from Naked Innovation in Barcelona will talk about transforming and innovating the agri-food industry. And we invite Roberta Sonina, a professor from Surrey University, to talk about transforming food systems. So that is upcoming. Okay, that is my part. And now I would like to invite Michele Suman to give his first presentation.
Okay, thanks a lot, Edward, and thanks for inviting me to this webinar. I'm pleased to share with you some views about food authenticity analytical strategies and solutions. And so let me just, after thanking the organization, try to share my screen. So please let me know when you see my screen. Can you see it?
Yes, perfectly. Thank you.
Perfect. Just trying to move back this part. Okay. Oh, okay, good. So, in the next 20 minutes, I will be pleased to introduce you on a solution that we tried to develop in the last years through collaboration also between industry and academy towards different kind of topics related to food safety and authenticity, but I will focus mainly in reality on the authenticity issues in the presentation, even if the border between the two things is quite well connected, let's say. And unfortunately, sometimes you move from safety to authenticity and vice versa in a very close way. Talking in particular about this point on authenticity, we can consider the fact that both for safety and authenticity, we are facing a global food chain lantern that is growing more and more in the complexity. So the scenario analysis I want to share with you is that we are more and more interdependent between small, medium, and large enterprises in these global food chain lands. Then, as all of us is aware, there is a geopolitical scenario that is increasingly complicated. And we have also a digital age into which the consumers spend a lot of time reading and exploiting social media, internet, etc., in order to exchange opinion and make more and more informed choices on the market. So this is the kind of scenario when I talk from the industrial perspective, we have to face and to consider. More into details about the supply chain complexity. This is just a figure that gives you the idea of a lot of different steps that move from the raw materials to the finished product, moving from transformation point to, let's say, distribution centers, storage centers, etc. And all the different points could be a weak point that can be affected by some risks, in particular for what concerns the authenticity scenario. And about the situation of the contingencies from the global scenario and the geopolitical instability, we have in different points of the world different kind of tensions or wars that can affect the kind of import-export, the kind of commercialization of raw materials and speculation on them. And so the risks, again, in particular on authenticity and safety is growing in this sense. Finally, when we consider more the aspect of the consumer's need, there is more and more the interest about variety claims, ethical aspects, and in general, the consistency of the label with respect to the content that consumers, as we said, are more and more aware and demanding at the same time. So if we want now more to focus on details of where we have to go in the next years from the analytical perspective point of view, I want to take you into the perspective of two different ways of working. One is the targeted approach, and the second one is the non-targeted, with complementarities between the two. And in particular, if we consider these two possible ways of working, in reality, I want to say that these are two possible consecutive ways. The right way of moving for complex issues from the authenticity and also safety, even if authenticity, as I said, will be the main point of this presentation, kind of workflow, start from the non-targeted methods because most of the time you are not completely aware of the risk. You are looking for anomalous signals in the system, and so non-targeted approaches could be the right one in order to identify some markers, some molecules, some features that then can be transferred into targeted and most cost-effective final routine methods. So this is the way of working of the future from an analytical point of view. And the workflow, I will try to illustrate it to you following three different examples: the egg product freshness, the risk of soft refined oils additions, and the geographical origin of durum wheat. Starting from the workflow, and so starting from the sampling plan, the first point is to be representative of the kind of world you want to model in order to identify the right analytical strategies, which means that, to give you the example of looking for an analytical solution for egg freshness, you have to create a model that takes into account of different suppliers, different delivery dates during the year, because obviously the temperature and the conditions during the year change a lot, and also considering different lots of production. So you have to create a sampling plan that is representative of the reality. And the second point is having a second step of validation of the analytical approach with completely new, let's say, batches, new lots coming again from the same representativeness. The second aspect is about the extra virgin olive oils. In this case, the focus was about the risk of the so-called soft refined fruits, so the so-called deacidification or deodorization of low-quality olive oil in order to dilute and adulterate the extra virgin one. So in this case, the model creation is planned through the right mixing of different suppliers, storage condition, and harvesting of completely pure extra virgin olive oils, and then you have to produce in some ways the adulterated ones. So in this case, if you do not have the possibility, obviously, to take them from the froster, you have also to set in your lab some adequate solution in a pilot scale in order to generate different level of adulterations. The final examples, again, for the sampling plan and about the geographical origin issue, in this case, rely in particular on going directly through sampling plan and through certified sampling protocols to take your samples to be sure about their real origin, and also to take into account of different harvesting campaign in order to be sure that your analytical solutions is independent from, let's say, the nature effect, and really relying on the geographical origin and not on, let's say, a different conditions of an harvesting campaign with respect to a following one. Then, if you move to the statistical treatment of your untargeted analysis through metabolomics, for instance, like with mass spectrometry, NMR, or spectroscopy, then the point is generating supervised models that permitted to differentiate and to classify mainly in two categories, fresh and not fresh, extra virgin or not extra virgin, Italian or not Italian, if we talk about, for instance, the geographical origin issue example. So simplifying as much as possible into a sort of, let's say, white or black, and so one class against another in order to be as much as simplifying the final results, especially if you look from the pragmatic industrial perspective. Then another aspect is the comparability of the results. When you develop an analytical solution, the main point is to have the possibility to reproduce the results and the modeling also in another laboratory. So I give you here the example of what we did with the extra virgin olive oil. We were repeating the kind of analysis and experiments in two different labs. In this case, Barilla and University of Parma labs in one side and University of Prague in another side, with different operators, different mass spectrometry metabolomics platform, in this case, an Orbitrap and a triple TOF instrument. So we were in different places, different instrument platform, different operators. And it's interesting to see that we can achieve, if the analytical development is produced in the right way, two models with the two platforms in the two places into which at the end different compounds can be identified. But the good point is that you have the possibility to reproduce the similar models, and I can tell you that in particular more than 80% of the markers in the extra virgin olive oils found in a platform were found also in the other one. So if you are able to reproduce in an interlaboratory study the results, then you have a very robust approach at the end. In the final examples, the final point is identify markers. So here you can, let's say, simplify the results of the three different case studies, saying to you that some kind of markers, free amino acids and degradation products were found, some raising, some going down for the egg freshness. Different polyphenols, derivatives, and fatty acids oxidation products were representative markers of the soft refined fruits for the extra virgin olive oils, and oligosaccharides derivatives were found as isolating good markers for the geographical origin of the durum wheat. Then the point is how to harmonize the approach for the marker validation. And in this sense, I give a suggestion of this very recent publication in the end of 2024, into which we were trying, together with a lot of other experts and colleagues in the world, to create an harmonized approach in order to make a final validation of markers for the authenticity. So I suggest to take a look on this presentation, on this, let's say, publication. The second aspect, the two ways of working I wanted to give you in this presentation is not targeted against, or let's say before the non-target approaches, but also the, let's say, screening versus confirmatory analysis. And again, it is important, in particular in the industry, to create a parallel direction into developing screening and in parallel confirmatory approaches for the different kind of risks. The example I give you now here is a first screening one, which is related to the spices. As you know, spices and herb sector is a very, very sector at risk in the Europe, but I would say worldwide for the fruits. And this is an example of thermal desorption DART mass spectrometry analysis that has been developed for a couple of spices chain at risk, black pepper and oregano. And this technology is an immediate technology that permits in a minute, let's say, to create a ramp of temperature to desorb directly the markers compound from the spice leaves directly into the mass spectrometer in order to generate immediately a sort of fingerprint of signals that can be exploited to generate predictive models, as you can see here in the example for the oregano, to validate typical versus atypical, so adulterated and cutted with different kind of leaves, oregano samples. And in a parallel way, this is an example for the black pepper. Again, you can generate in less than 1 minute a fingerprint and create with the right sampling plan, as said before, predictive models to identify completely 100% typical black pepper with respect to differently adulterated ones. And so this is an example of a quick screening analytical approach that can be applied in order to isolate only the samples that necessarily need to move for confirmatory analysis. Another example of screening, and we can come back to the geographical origin of durum wheat, can be considered here with the infrared spectroscopy. You can simply grind your durum wheat kernels and then you can generate immediately in a few minutes an FT-NIR spectra, and there are some specific regions of the NIR spectra that can be isolated in order to find features that can be correlated with the geographical origin. And again, a model of prediction of Italian origin in this example with respect to other countries can be generated for a quick screening with the infrared technology. At the same time, you could have the need then to confirm the risk and to confirm the frauds or not. And once you have screened with the infrared, then you can go to confirmatory analysis, in this case, applying isotopic analysis. So in this way, we developed a combined approach that measure isotopes and multi-elemental different features in the durum wheat, and generate again a classification models of Italian versus non-Italian samples. This is a two-step model. A first step is applying Straussian isotopic ratio in order to isolate European samples with respect to Mexico, America, Russian, or any extra European ones. And then there is a second aspect of the model that exploit a selected number of elements that permit to discriminate the Italian samples within the European different countries. And at the moment, this method that apply these two progressive steps permit to isolate mixture that contain at least 15% of non-Italian wheat within a mixture. That is absolutely compliant with the potential risk of fraudsters that usually go more than this kind of percentage in order to have a real economic gain in this kind of fraud. Going again to example of isotopes for confirming risks from the authenticity point of view, you can exploit, in this case, light isotopes analysis in durum wheat in order to see another kind of fraud risk, which is the organic versus conventional declaration. And we isolated compound-specific isotopic ratio of nitrogen and carbon in a selected number of amino acids in order to separate organic versus conventional wheat and wheat-derived products. Here you can see that the approach can be applied to differentiate the conventionals versus the organic, let's say, nitrogen and sulfur isotopic ratio, applying this approach not only to the wheat, but also to examples like bakery products like cracker and biscuits or pasta products. So then you have to take into account that the processing can affect the nitrogen of some amino acid, but if you combine the isotopic information of the bulk and some selected amino acids, then you can apply the protocol not only to the raw materials, but also to the finished product. And this is also important, having an analytical strategy in the industry that can be applied along the chain and not only in the raw materials or in the finished products as well. Another example is about the meat speciation. In this case, a complex product like a bolognese sauce is at risk because of the high thermal treatment impact. If you try to analyze this fraud of, let's say, mixing different kind of meat you can be at risk if you apply, for instance, the PCR technology, because the DNA can be destroyed by the sterilization temperature of the industrial food sources, meat-based. And at the same time, you could have a denaturation of proteins also when you analyze with ELISA methods. And in this case, mass spectrometry can be the right solution, because you have the possibility to digest the samples and generate right marker peptides that can be correlated with the collagen part of different kind of meat products. And you can isolate specific peptide signals and be able to create calibration curves that permit to differentiate not only the classic fraud of beef in pork, but also to differentiate other kind of meat species like duck, rabbit, chicken, etc. It's just a matter to have availability of the raw materials and create in pilot plant calibration curves of the different mixings in order to then isolate opportune peptides that permit to isolate the different kind of meats and solve these authenticity issues as well. Finally, and a final couple of examples, a screening of geographical origin of hazelnuts. Again, near-infrared approach is a solution, and you can generate with near-infrared, like we did for the geographical origin of wheat, good models that permit to isolate different kind of geographical origin of the main producer in Europe, Georgia, Azerbaijan, Turkey, and Italy, for the different point of the chain, raw hazelnuts, roasted one, and hazelnut paste. If you want to confirm then the risk in the workflow, then you have to move again to isotopes. And in this case, applying isotopes what concern the oxygen and carbon, you have information about the confirmation of the geographical origin. In particular, if you look to the carbon, this could be correlated to the different altitudes, the average altitudes in the different countries of production of the hazelnuts, which is correlation with the absorption of the carbon dioxide. And on the other side, if you look to the oxygen ratio, then it can be correlated with the combination of rain and annual temperature that are different with respect to the different geographies of the main producer of hazelnuts in the European market. So again, the right way of moving, and I want to stress this, is developing parallel screening and confirmatory solutions. This is the more pragmatic way of working for the industry in the future. And with this kind of helicopter view of different case studies, I'm concluding this presentation, and I also be completely available for you for further questions. Thanks again.
Okay, thank you very much. Yeah, we propose to have the questions after the presentation of Francesco,
yes,
so we can both at one time. I see
yes,
Isabel is waving. Please keep your question so that we can have the Q&A session afterwards. Thank you very much for a great presentation, and now I give the floor to Francesco.
Thanks again.
Thank you very much. So I'm Dr. Francesco Mureddu, and I am a Vice President at the Lisbon Council, which is a think tank based in Brussels, where I am basically responsible for, let's say, for all the European Commission accounts, so for all the European Commission projects. So I'm going to present very quickly what are the technologies, disruptive technologies that can have a transformative impact on food and food system. And then I'm going to focus on 3 projects that the Lisbon Council is partnering with, and that can be very interesting for the audience. So starting from the challenges are of course very known. The fact that by 2050 we basically forecast to have 9.8 billion people in the planet, and so the idea is to be able to feed all these people. In that regard, the food systems are under pressures due to climate change, population growth, but also due, as my colleague was mentioning, due to basically the instability that we have from the security point of view at world level. In that regard, disruptive technologies can help. In fact, they can help the food system to be more efficient, sustainable, inclusive, and resilient. And with disruptive technologies, we mean artificial intelligence and machine learning, big data, blockchain, interconnectivity, IoT, open data, and edge computing. Of course, AI is the most relevant at the moment, especially generative AI. So for what concerns artificial intelligence, as we know, so this is basically the simulation of human intelligence for what concerns reasoning, learning, and problem solving. There are several applications in food, precision farming, of course, like prediction and crop monitoring, the prediction of yield and to monitoring of crops, forecasting of demands in order to optimize the supply chains, and analysis of food quality, for instance, through imaging. And the impact, of course, of the use of artificial intelligence is enhancing the decision-making process for farmers and producers and reduce wastes and improve efficiency. In particular, machine learning is basically a subset of AI, in which systems can make prediction based on data and can improve and their parameters, make their parameters more precise through data training. Specifically, it can be used for disease detection in crops or in fruits via image recognition, but also automated recipe recommendation and optimizing food processing. So the impact, of course, is to drive innovation in food production and reduce costs and enhance sustainability. Big data, of course, is very related to machine learning in the sense that machine learning, that the training of algorithms can leverages on huge amount of data. So big data is basically the process of examining complex and large data sets and databases in order to uncover and visualize trends, insights, and patterns. So the applications in food, of course, are the forecast and prediction of the weather patterns, the crop performance, also basically studying the consumer behavior through nudging, and the monitoring in real time of the global food supply. So big data can help, of course, to personalize nutrition solutions and inform decision making. Blockchain, which is also widely used in the projects that I'm going to present. As we know, it's a ledger technologies in which ledgers are decentralized and immutable in order to have records, to record transactions that are transparent and that are securely and immutable, are secure and immutable. In that regard, it can be used, for instance, to ensure traceability of the food from farm to fork, so to basically better understand and to be sure where the food comes from. And this, of course, reduces fraud and inefficiencies and builds consumer trusts. Interconnectivity, in general terms, is basically exchange of data between system devices and networks. This, of course, can be applied to smart farming, to monitor the storage, and to automate irrigation systems. And this, of course, will enhance precision agriculture and minimize resource waste. And then Internet of Things, as we know, it's basically the connection of different devices that collect, share the data on internet. And this can be, for instance, used for predictive maintenance for agricultural machinery and the likes. Also, in this case, it increases consumer engagement and transparency and efficiency. Open data is very interesting because we are talking about putting information that is shareable, accessible, and usable and reusable in particular. And this can be used, for instance, to make data available for collaborative research on food, or making basically data available, accessible regarding to soil and weather, to all the operators and also the researchers, and of course share agricultural best practices globally. And in that regard, the European Commission is moving a lot towards trying to make data available and reusable as much as possible. And this will basically reduces inequality in access of resources, because if you put the data on internet for everybody to use them, it can help also, let's say, operators that come from lower income parts of Europe or other countries. And finally, edge computing, which is basically the paradigm of processing data closer to its source. And this can be used for instance, for real monitoring of supply chains, for localized data analysis for precision farming. And this will improve efficiency, reduce latency, and also several projects are studying to what extent edge computing systems are also able to reduce the energy consumption with respect to the cloud and the big data centers. So all these technologies, of course, can enhance their own impact if they are combined together. There are several synergies. Of course, AI and big data are naturally combined in order to enhance predictive analytics, IoT and blockchain for traceability and transparency, and open data and edge computing for driving localized innovation. We move now to example of projects in which some of these technologies are used. So Watson, combating food fraud with advanced technologies. So Watson is an Horizon project that basically wants to develop a holistic framework to detect and prevent fraudulent practices in the food supply chain. There are several of these technologies utilized. So artificial intelligence is used to analyze data and to identify patterns and anomalies related to patterns of anomalies indicating food fraud. Big data analytics, of course, aggregates vast amounts of data that can be used for traceability and decision making in general, and also for the analysis of pattern. Blockchain is used to securely recording transaction and production histories of food in the pilots. Internet of Things, it's used to connect devices to monitor condition in the supply chain, and edge computing to enhance the analysis of the local analysis of data. So the impact on food sectors, of course, is the improvement in the ability to identify and also to stop fraudulent practices, and also improve consumer trust, because consumers will be ensured that the products are safer and more authentic. Alliance, another project on enhancing traceability and transparency in quality labeled food supply chains. So this it's a very much related project, and wants to provide an holistic framework to safeguard data integrity, enhance traceability and transparency. And so basically artificial intelligence is used to testing and verify on-site product authenticity. Blockchain, also in this case for data integrity and traceability. Internet of Things for the collection of data, and open data to promote best practices in a transparent way. So the impact on food sector is more basically creation of more resilient ecosystem, and reduce adulteration and food fraud. Data for Food 2030 that I directly follow. So advancing the data economy for sustainable food systems. So basically the idea of this project is to improve the understanding of the data economy for food system by expanding its definition, and also to see the impact basically on the overall economy and on the society of the shift and all the boost in the data economy for food systems. So big data analytics is used basically to study the impact of the data economy for food system. Open data, basically the project encourages the sharing of data to promote innovation and inclusivity, and artificial intelligence also is used to basically predict what will be the trends in the data economy for food system, especially in particular machine learning. So the impact on the food sector is to support basically the transition to sustainable food system, giving in more data-driven insights, identify drivers and barriers to the data economy, and provide future scenarios and roadmap for the desired future state of the data economy. Finalizing, so as we can see that the lessons learned for what concerns these technologies are basically the same or similar to all the sectors, like initial cost in terms of investment, lack of technical expertise and resistance to change, but of course ethical concerns which are related to data privacy and equity in technology access, but new policy frameworks, public-private partnership, and the, let's say, the boost of research innovation can help in that regard. For what concerns the trends that we can see, the convergence and the combination of technologies for sure, the rise of personalized nutrition, and also circularity in the food system, which is something that has been pushed by the European Commission, in particular through the Horizon program. Thank you very much.
Okay, thank you very much, Francesco, for an excellent presentation. I hope Michele is still with us.
Yes, I am.
Yes. Because maybe now both you can keep the camera on. So I was wondering if there are questions. I saw that Isabel wanted to ask a question when Michele had just finished. Please, whenever you have a question, you can ask it now. Otherwise, I start off. I have a question for you, Michele. So what struck me is that you almost always propose a combination of a detection method and a digital technology. And we in Titan, we of course we do this in many cases, but I was maybe still having in mind that most of the work in these aspects are done in the laboratory, so running tests. But maybe you can comment a little bit on this development.
When you say digital technology, you mean, let's say, the statistical elaboration, let's say, or the exploitation of machine learning, something like that?
Yeah.
Okay.
Yeah.
Yeah. The good point is that this kind of combination is particularly, let's say, effective in order to generate robust models. And the competence of the lab itself, to me in particular, if I look to the general kind of context of industry in particular, seems to be not still ready for that. While I can imagine the potentiality in, let's say, big external laboratory networks or something like that to reproduce these kind of strategies in a proper way. If I have to imagine to replicate some of these approaches in, let's say, other industries, especially small and medium one, could be in difficulties specifically for this second aspect, so the data elaboration. There's still a lack of professional figure, jobs role in the industry completely dedicated to data elaboration. And this is something that I think is perfect connection with what Francesco showed also about, let's say, a lot of projects related to artificial intelligence, machine learning for, let's say, precision farming, etc. The role that scientists, data scientists, should have in the future in the industry will be more and more relevant and partially perfectly connected with the big data generation from the analytical instruments in the lab.
Thank you very much. Yeah, I would think that that companies have a certain budget for their analysis, and that is something that they want to spend or can spend. And from what I hear from, let's say, hygiene and quality managers, is that it's always quite restricted. So when they want more, like when they would like to have this data elaboration, it adds to the cost. So I think that could be an internal problem within companies.
Yeah.
But I can understand that. Yeah.
Yeah, and I can also comment the point that this is strictly dependent on the kind of strategy that the company should follow. I mean, depending on the relevance of the raw materials or the specific product, something can be completely outsourced with a budget, as you said, from the quality assurance. But there could be some cases into which keeping the property of a database or having your own data elaboration could be a strategic value and added value for a specific raw materials, for instance. So it's a matter of compromise.
Yeah, and it could be that a scientist that is hired by a company can work on more topics, that he or she does not only have to focus on food safety or authenticity, but maybe even on processing efficiency or whatever.
Definitely, yeah.
Yeah. Okay, thank you. Now Isabel is waving, she's back again. So please, Isabel, ask your question.
You can use your microphone now if you want to.
I think we can't hear.
And I move on. We wait until Isabel comes back. But she.
Okay.
Francesco, I have a question for you. Can you touch it a little bit in your presentation? Can you comment a bit on the difficulties in sharing of data? Within the Titan project, we try to look at different supply chains, and when we start discussing, okay, Isabel is there. But what I see is that you're still mute on my screen, but
maybe she can type the question in the chat.
Yeah. Manuela, okay. And then I go to Francesco. So there's sometimes difficulties in sharing data, and we look at supply chains. So maybe you can give some information about this topic.
Yes, well, I think that the usual problems that are related to a lot of sectors, for instance, the lack of standards, standardization, basically the fact that the data can have inconsistent data formats or protocols that of data collection can be different, also protocols related to storage, to exchange. So this can be a problem, or data ownership and trust. So companies, of course, can be reluctant to share their own, but even public administrations actually are reluctant to share their own data. In many projects in the past, we basically talked to agencies, even within the same public administration, and everybody was reluctant to give the data in order to create unified databases, because data is a kind of a currency that gives you some some relevance. So there is a reluctance to share. There is and also there can be a lack of trust, but in principle the fact is that data are a currency, and that and so people is reluctant to share them. Of course, data privacy, it's a problem also if we are talking about sensitive information. So information should be basically anonymized first, and this can be a problem. But also there is a kind of an expense, some expenses and a cost in basically ensuring data quality and accuracy, because when you share the data, you need to have data that are of high quality, and so that they are assessed to be high quality. So this also can be an issue.
Okay, thank you. Now I would like to see if Isabel can speak and we can hear her.
Can you hear me now?
Yes?
Oh, perfect. Okay, sorry. I don't know why I never had the opportunity to end and mute me. So, thank you for both your presentations. So my questions were already answered from this series of things, but I had a question for Suman, Michele. You seem to have done a lot of work in the area of food analytics and spectroscopy, which happens to be the same area I've been for the past 15 years. And we actually have published a lot of stuff in adulteration and identification and so on. I'm the founder and CEO of Telspec, which is a small device that is portable, near-infrared spectrometer that is portable. We were also the winners of the food challenge scanner, food scanners challenge that the EU put out in 2015. And just like your presentation shows, a lot of the large instruments that cost, in hundreds of thousands of dollars from Thermo Fisher and so on. And no mention on the different portable instruments like Telspec that are in the market now and that allow, the lab to be actual on the spot. And there's been enough studies and published studies by different groups that show that the metrics obtained by small near-infrared spectrometer are pretty well close to the ones for the large laboratories. But we still, as a company at least, we still don't see that migration from the large lab equipment into the lab on the spot, on the site with smaller instruments. And one of the difficulties is actually what Francesco just mentioned, which is the data, sharing data, a huge problem. So you create the models to authenticate, say, olive oil. But there's two things about this. First of all, olive oil from Italy is not identical to olive oil from Spain or Portugal, or much less from olive oil from another really different region like Asia. So there is a huge problem there because the data is not exactly the same and the markers for authenticity are not exactly the same. But then there's the data sharing. And what do you propose? The question is what you propose to enhance that sharing of data and to bring that large multinational companies like Barilla less afraid of the sharing of data, because at the end of the day, they actually benefit. And we have done, silos on our cloud for the different projects that we actually have with different clients. But it is a problem that we see that eventually doesn't benefit anyone. Doesn't benefit Barilla to just have models for olive oil in Italy. when Barilla may import and put in their bottles olive oil from Guatemala. I don't know if Guatemala actually has olive oil, but as an example. So the data sharing in the end actually benefits companies. So I just wanted both of you, Francesco and Michele, to actually talk about a little bit about the data sharing and what you propose, and also talk about how this is evolving into instruments that are portable and eventually into a phone.
Maybe, I don't know if I can start to answer. So I'll start. Thanks for putting on the table these aspects, because especially for the sharing of data, while Francesco was talking, I was also trying to react, and in fact I raised my hand for that reason, because the reluctancy about the sharing of the data in general is a problem that, yeah, definitely we have seen also through different European funded projects as well, when we try to push on that. And I think that on the other side, what you said, Isabel, about the value of sharing the data is really, really important, because we have several facts and a situation already happened in the past that demonstrates clearly that if in the chain we share a strategy and we share a solution that could be publishing and analytical methods, for instance, for fighting the frauds, this is much more better than keeping, let's say, a secret under the door, the solution for itself in each single company or in each single lab. The robustness and the defense against the fraudster, in particular, if we talk about authenticity, is much more higher if we try to share the solution. This is for sure. On the other side, there could be some kind of IP issues and general reluctances on the value of databases and data from a single company that I can understand. And my personal view is that a way, not probably the only, but a way to solve partially this issue is go through associations, try to protect or anonymize the data through sharing databases or information, not directly from the single company, but through the food company associations, the food category associations. That's a way that probably could be followed. Then if I go on the point of the portability and the portable instrument, yes, I think that you are right when you say that in the future this will be more and more implemented, and I think that this will happen. It's a matter of time, and at the moment, from my experience, while I'm totally in favor of low-cost technologies to be applied for the screening, as I show, because when we talk about application of an infrared measurement with respect to an isotopic ratio of strontium, we are talking about two completely different kind of costs. So I'm in favor of going to low-cost technology, especially for screening. But then when we move to portable instruments, I think that some, at least doubts from the companies or from other scientists, relying on the fact that reproducibility, repeatability of the result, especially in real conditions, to my experience at least, need probably a little bit of more robust demonstration, some step in advance. But then the other aspect for me is this is strictly depending on the kind of, let's say, operator that exploit the portable instrument. What I mean is that I'm completely convinced that there are already on the market some portable solutions that can be exploited from a quality control operator or a line operator that has been trained for using it directly in the field. But I'm a little bit skeptic about, let's say, a normal consumer, a normal person that is, let's say, going to the restaurant with a portable tool to check for the allergen in the dish or something like that. I see some, at the moment, some risks still on this. So portability, yes, for me, but strictly depending on the at least training and a little bit skilled operators, and not sure that up to now we are in the condition to distribute the portability solution to everyone. That's my impression, my honest thinking on that.
Yeah, I must say that you have a point there. We did start initially our company with a B2C focus, and soon we saw that we needed to do a B2B, not a B2C, because of this point exactly, because of the variability of the user that comes from the user instruments. But even on a B2B, our concerns in terms of growth is that, of course, we have these very large companies like Thermo Fisher or Parker and Hellman discarding all the little instruments, although there is a lot of scientific evidence that they are as good in many situations, especially for counterfeiting. Very easy to do counterfeiting with NIR spectroscopy. But so I almost feel that, false information is put out into the B2B market to stop the SMEs to actually get these instruments in the hands of the different groups that could have it, the farmers and the fishermen and God knows the retailers and so on, to test for whatever it is, for the specific stuff we're doing. We're doing, for instance, fish freshness based on K value, which is, a post-mortem information. Very possible to do and very good results to get. But again, a lot of evidence that it's similar by some universities, but a lot of bad misinformation. And I wonder if it is because these large companies are trying to desperately miniaturize, get their cloud stuff in order and miniaturize the instruments. And then when they have a miniaturized instrument, then they can compete. I don't know, but I do know that sharing data is one of the biggest issues. One big example I have is that we had just finished a huge project funded by EIT Food on fish adulteration for whitefish. So we could scan a fish and say, okay, this fish is actually not sold, but actually pangasius. Because it was in fillet form. And I took this to Japan, and the instrument and the values were all completely wrong because the fish species, they have similar names, but it's different within the species. It's a different fish, kind of. So we were not getting good results at all. And it's like doing a project in Ghana where we were doing cocoa beans. And our partner in Ghana said, we're going to give you cocoa beans. We got to have all these students coming in and scanning cocoa beans all over. And we're going to, reference them with the different parameters. And then we looked at the data, and the data was clustering in 7 different regions. And I went back and said, how is this possible? Why do we have clusters, 7 clusters? And the professor on the other side said to me, you know what? Those clusters are actually the regions. So the near-infrared was able to pick up which scans were done in what region. We could differentiate the Ghana cocoa beans per region based on NIR, which was unbelievable. And at that stage, it really dawned on me, this project is huge, to scan all the food in the world so that people can test, or farmers can test, or so that to improve. It's a huge project. It's like Google Maps. It's like creating a Google Maps. And for this, you need either a huge company that can do this, with a lot of backing, or we need a collaboration of many companies. And I never seen it, even in the different proposals that Francesco has put forward. I've never seen that idea, which has been an idea of ours since the beginning. Imagine a map where you actually see things about food, not just, about roads, but food. In this here is, the tastes and the food and the information about the food. I don't know if you know this or not. I have a house in Montreal because I love the area, and Quebec government actually has a site where you can differentiate. You can go into the site and see exactly what food is being sold. Like, so you can say, okay, in the supermarket, I saw this food, who produced it, how many people were in the employee, what is the employee policies, where the food was sourced, what the ingredients are, what the allergens are, everything about that food that is being sold. We still don't have this in Europe. And I look at it and I'm like, how is it possible that we still don't have this? It's something that should exist. And it's something that could be attached to a scan, a fingerprint, like what you just said in terms of the fingerprints. So easy to do. I mean, it's massive work, but so easy in terms of technology that we already have, and then use of course, the blockchain to actually, permanently, establish it. But it's not there, and I think it's because, and you said it again, the large companies don't want to collaborate. I remember at EIT Food, we had a consortium with Nestle, which eventually Nestle just walked out because they didn't want to share because of IP. Whatever the IP reason is, they just didn't want to share. So the project died. So anyway, I just give you ideas.
For sharing this, Isabel. I think the first thing we have to do is to give Francesco the opportunity to react.
Yeah.
No, I perfectly agree, and point taken. I can add something regarding data sharing. I mean, one idea that has been pushed at the moment by the European Commission is the one of data spaces. I mean, it's a concept according to which data will be collected and made available also through visualization, but still, there are a lot of problems and a lot of difficulties in doing that. I worked directly to the establishment of a data space for urban data regarding environmental data, and to put all the stakeholders together and to gather their availability to provide the data was very difficult. And it was basically a small city in Italy, Ferrara. So in the food system where there are a lot of operators, this is going to be even more difficult.
Okay, thank you.
Maybe I don't know if I can add a little bit more, either if I have time to this point.
Yeah, that's okay. Yeah.
Thank you. But very quickly, I think that there is a point about the authenticity of the reference samples. What's said by Isabel, imagine this kind of a new Google Maps of Ghana, let's say, or a country through the infrared analysis in different regions. That's amazing. I totally think this kind of sharing of information between companies in order to generate a database that otherwise you don't have for yourself the force to generate alone. I agree. The point is how to demonstrate the authenticity of the reference samples that are inserted in the database, because there could be some doubts about the generation of this big number of data. This implies to exploit blockchain or some ways to certify, demonstrate the real authenticity of the reference samples that has to be used for creating the database that then can be the core of this kind of models. And the other aspect is about, let's say, Montreal and Quebec. I was in vacation during the last summer on that place, so I've seen with my eyes what you said. Yes, for sure, something similar in Europe would be desirable, but yeah, it's feasible, definitely feasible. The point is, it's a matter of final cost of the product for the consumer. I have to say that this is a big discussion I've heard several times in the last period. Introducing, let's say, a QR code and the blockchain technology for tracking the product, as you said, yes, you can do it, but inevitably it generates higher cost that has to be transferred to the final price for the consumer. And we are in a period, in a moment, that I see industries more and more trying to reduce the costs for several contingency situations in which consumers do not have affordability of the products. So we are, I think, in a sort of counterflow that let's say, push in the opposite direction, even if the feasibility is on the table.
Okay, thank you. I think with the legislations that were, let's say, or approved or discussed last year in the EU, some, let's say, tracking and tracing and data sharing is needed, like with the EU deforestation regulation, or with the let's say the forced labor regulation. So because companies need to be aware of what is happening in their supply chain, and this will be starting, and of course it will grow in time. But I think those are situations where it's needed. When you talk about informing the consumer, like when you have a QR code on the packaging that gives information, as Isabel and you mentioned from Montreal. So we have one SME in Titan that is doing these things. They design really nice QR codes, and what they say is that they can help the producer to tell their story. And yeah, let's say I think especially smaller companies, they benefit from this. So it could be a cost for them, but it can also help them to find their customer, or the customer to understand what they're doing and to like what they're doing. Maybe they like the family, or maybe they like the region. And one of the ideas, and I think this is happening in a project in Piemonte now, is that this is coupled to tourism. And when you have in a certain region 10 or 15 small producers, and when they all are united in the same program, they all have the QR codes on their products, and they can organize visits for tourists. They can have some shared activities, and then it can have even benefits for the region. So there can be more reasons to do these things, to share this information, than only to sell your product. Maybe you can convey your messages, but maybe also you can have collaborations where you work together. Any reaction on this?
Yes, I
Yeah.
think that I agree with you. The QR code, thinking to tell a story, as you said, that's perfect. I think what you gave an example for the tourism connection with the local producer, etc. But also I can tell you that also in Barilla we have examples of this kind of exploitation, and I know that this is surely an added value. The real change of the costs, for me at least, is when you move from narrowing the story of the product, giving information to the consumers about the product, as you said, or trying really to demonstrate, let's say, I'm just, let's say, inventing that a biscuit in that specific pack that Mr. Robinson took from the shelf of the supermarket in Montreal is coming with eggs that were, let's say, obtained from that specific supplier in that day, in that moment. So what I mean is, if you really want to exploit the technology in terms of tracking in a complex finished product, a lot of different ingredients for the consumer, demonstrating every point of the chain before, what happened for a single lot, etc. This is probably a cost not so low with respect to exploit the technology for narrowing a story or telling a story that is good, useful, and relevant for also for the company itself in terms of commercial business, I think.
I think the second option you gave will be very data consuming. And it will require really a buy-in from the companies to do this. Well, let's say more the first option is, it works really well with shorter supply chains.
Yeah,
And
I agree.
well, you can see there are specific shops where they sell regional products, and then it's very easy to communicate where the oranges or the potatoes or the meat comes from.
Yes. Yeah.
Yeah. Francesca, I have a question for you about the project you shortly mentioned. Can you explain a bit how is the link with promoting, let's say, company activities? Are there SMEs involved? Do they get some support? Is there what is their position in the projects, and how can they use the technologies that you described?
So SMEs are involved as partners in several in all the projects of several SMEs, especially in the piloting activities. They are funded as partners through the Horizon Europe program. For what concerns the technologies that will be produced, the tools that are being produced, and the data that are being produced within the scope of the project, the idea is to have everything available to third parties. The projects are entering now in their final phase, so the discussion about IPRs among the partners are basically getting into the core moments. But the idea is to produce to give open access and open source as much as possible.
And how could, let's say, companies benefit from these developments?
Well, I mean, the idea is they can reuse systems that are produced by the projects, and also data that are produced by the project. Especially if we talk about data for food system, data for food 2030, we are producing a set of models for elaborating the impact of the data for food system. So these methodologies can be reused by companies, but also, the information that we provide are also useful.
What we see in the Titan project is that we can have companies involved that are technology providers, that are experts in AI or in blockchain, so that they make business offers where they really bring the technologies to other customers. There can be customers using this technology, like to collect information in their supply chain. But there can also be companies using this technology to build an offer to bring to other companies, like with precision farming. We have Agricolis in the project, so with help, they set up a system that they can then bring to the farmers. So at least I can recognize three different positions for companies in this field, in this area. I don't know if you see the same or if you also see others.
Yeah, we started. Maybe you can give me more information about what Titan is actually doing in that respect. But I see similar actions possible.
Well, yeah, we are now in a cluster together, so we can have more contact. But it's more about let's say, how companies can benefit from all these developments. Okay, we had prepared some questions. I propose that we stay together. Here, let me see. Well, there was one question for Michele that I have is so how to manage the situation when you have developed a great method, but let's say this way, it's not yet part of the approved list of methods. And maybe this is something that you need to be aware of more in food safety, because methods need to be approved before they really can be part of a program. But maybe this also works like this in authenticity.
Yeah. So you mean if the good approach is not yet, let's say, inserted into a framework of legislation? Have I understood correctly? Okay. Yeah, I think that there are two different steps. A first step is the kind of relationship you have as industry with your suppliers or your end users. It means that if you have a good strategy, and the first, let's say, preliminary point is at least demonstrating the scientific reliability of the approach. So having real proof from the scientific point of view, from peer reviewing of other experts, from publishing, from having a real demonstration of the scientific applicability. So once you have this, at least you can go to your suppliers or along your chain and say, okay, I have this approach. I want to control for myself or through some kind of lab collaboration, applying this approach, applying this method, and please be aware, you as my supplier, that I'm going to control in this way. Can we share the solution? You want to be aware that in our contracts, in our agreements, I'm going to control also applying this solution, even if it is not yet a legal one, let's say. And the second step is if you are if you believe that this solution is useful for the chain and is really applicable, go through the normative bodies. So try to take on the table of your national normative organization or the European SEM committee to, let's say, take on the table to this kind of organizations the approach. Try to promote interlaboratory comparison and, let's say, follow a potential normative way to achieve in the future an official methods.
Yeah, thank you very much. Very good. I see that Andrea has a question.
Yeah, can you hear me?
Yes.
Yeah.
Perfect. Hello, thank you both for your presentations. I wanted to ask a question regarding something that you mentioned, especially Isabel, I think, mentioned during her intervention, is the role of consumers themselves. Because I come from a different sector in European funded project, that is the energy one. And what I saw there is the fact that transition there relies a lot on the role of consumers in some case. So consumers are not anymore just consumers, but they are also prosumers. They enable the transition. And so I wanted to ask if we are going to see something similar also in the food system and how. So if digital technology can be enabled directly by consumers in some way.
I don't know if Francesco wants to start or me.
Yeah, please, Michele.
Oh, okay. Well, Andrea, from my perspective, I think you are right in the medium long term at least. If I understand your point, me as a consumer of a car, I'm moving with my choices and my decision also from the energy of my house, etc. Let's say, I'm an actor of the transition. And if I understand what you mean also for the food, the kind of ethical needs, the kind of changes in habitudes from the dietary point of view, etc., the kind of change of ages of the consumers, categories, etc., this will drive in some ways the transition. Yes, I think so, but probably in a slow way. That's my impression.
My opinion, let's say that in general terms it's possible. I think that people can be prosumer in the food system, maybe for what concerns hiding data sharing, the data that they can basically collect from their consumption practices. And also they can be part of the system if we achieve circularity, for instance. So if the waste is then reused basically for energy production, for composting, for instance. The fact that they will also produce food, it's possible to a certain extent, but I think that with the fact that most of the population is urbanized and will be more urbanized over time, probably this will be a bit less relevant with respect to other basically sectors like energy sector, in which districts can be energy positive by producing the energy that they consume. But the hydroponics, I don't know, this kind of agricultural methods can help in that respect.
Yeah, thank you both. I agree with both of you. In some cases, when I refer to prosumers in the energy sector, of course, maybe in the agricultural food production, it's the consumers will have a different role. Maybe they won't produce food, but maybe they're gonna be, I don't know, more active in sharing data, as you said, Francesco, or other actions or supporting, I don't know, detection methods in some ways. So yeah, but thank you.
Okay, Isabel, you want to ask a question?
Yeah, I just wanted to complement what the question was. So actually, when we started a company, we thought that we would give this small instrument in the hands of the consumer would scan food away, and that this food, we would have photographs of it, we would recognize what the food is, and that we would eventually be able to differentiate the food and, through large, vast data, and benefit the consumer in terms of, information on the food of what they were eating. I still think that's possible. I still think that, it would be an amazing project to do and to have. I was recently reading the book by someone that most people don't like, Yanis, Neo-Feudalism. And he does say that Europe does not have cloud capital. And it's true, we don't have a large company in Europe that manages cloud. And food would be the perfect cloud capital kind of company, because we as Europeans, we really care for our food, and we care the way we grow our food and the way we brand our food. We're not like Americans that, food is just simply an entertainment that you have to do. So it would be a great thing to do, and it'd be a great project to be funded to create this, huge cloud data that consumers would be, engaged and incentivized to better their world and better their health. I still hope that one day this will happen, and I still hope I'll be part of it. So I very much see this as possible. And in fact, I believe that we only change things from the ground up. We only change these horrible counterfeits that exist if consumers start saying, I'm sorry, but I'm buying that olive oil that is being certified, that is being authentic. I know it's a bit more expensive, but that's what I'm buying because it's my health and the health of my children. So, and I think that goes hand in hand with the values we have in Europe, which are the right values, especially in the geopolitical situation that we face ourselves right now, where, there's so many false information and that it's even hard to differentiate what's false and what's true. So I hope that, people like Francesco can, one day say, hey guys, let's do that dream. Let's get the Google of food into starting with Europe so that we know, imagine that in terms of tourism. You would go to any place and you know exactly where it came from, what information it had, how it was grown, who benefited, was it fair trade, and so on and so on. So I just wanted to compliment it. Okay.
Yeah. Thank you very much. We are running out of time, and personally I have to go to a meeting now, but I would like to thank Francesco and Michele very much for your nice presentations and great answers on the questions, and Manuela for organizing the webinar and making it work, and the audience for listening and asking great questions. Thank you all very much, and look forward to meet you again next time.
Thank
you.
you.
It was a pleasure.
Bye-bye.
Thank you.
Bye-bye.
Bye-bye.
Bye. Bye-bye.